Okay, now we're ready to set up our source for our simulation. So we could do it here, but just to be neat and tidy, we'll do it in another geometry node, in another geometry soft network. So I'll call this out woman, and this one out man. Maybe give these some colors, why not? Purple. And let's jump out. I'm going to create another geometry node. Bring this over here. Okay. I'm going to call this crowdsource. Oops. Crowd source. Okay. Jump in here, grab an object merge. And we're going to go ahead and find those agents. So agent setup, add man, and then add one more. Agent setup, add woman. So we got them both overlapped there, which is okay. And then grab a crowd source into the left input. Visualize that. Okay, so we're just seeing the woman at the moment. So here we can add up all our randomization. So you can either do it in here. You can also do it, you know, with attributes coming in. So you know you can randomize the layer based on attributes coming in. So if it's based on any geometry, things that you could be painting onto a grid where you want the agents to go. Okay, all the kind of standard Houdini stuff that you can do playing around with attributes can be done here also. So first of all, we want a mix of the man and the woman. Okay, so woman and man. So there we go, we got a mix of them. We want, at the moment they're all wearing the same clothes. Let me just spread them out a bit. There we go. Okay, at the minute they've all got the same clothes on, so these are the layers that we built. So we can also randomize the, where are they? Clip time current layer. So if we go back, I think there were 6 in total that we made. Layer name 3, why is that? 5, oh, I need to rename these. 1, 2, I thought I did 2, 3, 4, 5, 6, that should be. And here 6, 5, 4, 3, 2, 1, yeah, perfect. So yeah, we need 6. 1, 2, 3, 4, 5. That's annoying. It doesn't matter, but just irritating. There we go. 5 and 6. And if you want, you know, more of one or less of any, you can change the weights, but you know, an equal distribution is fine for me. So there you go. You can see we've all got the same. Sorry, we've all got different clothes on there now. Some got hats, some don't, some different hair, different shoes, and so forth. The scale, so if we look at the scale of these at the moment, they're really big. So these that's 25 meters across, so we got some giants here. So if we go to randomize scale, and first bring the general scale down to 0.1, and that should be closer to you know, real world scale. Bring these in. Space F to come in closer. Something weird going on there, but don't worry, there's some kind of problem with the updates there. I think because the scale's in minus probably. So yeah, let's take a look at that. Randomize 0.05, let's say. There we go. Even less. 0.05. Well, if I put it to 0, there we go. So that's 2 meters. So that's about right, yeah. maybe a bit big, but it doesn't matter. This, as I said before, this is more important for, it's really important for ragdolls. So you'll be doing a RBD simulation there, essentially. And for the physics to be correct, you need the correct scale. So we'll just add a tiny bit of randomization there to the scale. Okay, not too much, don't go overboard, you know, just a little bit. What else? The initial state. Okay, so the initial states, the options it gives you here are the clips that you've got. It's kind of a bit of a gotcha, this, because the state is something within DOPs, within the simulation, right? I'll just quickly drop down the DOP network and show you. Right, so the crowd state here. So the state can be anything. You could have a walk and a run. Maybe we'll do it like that just so I can show you, okay? Because typically I would, for each clip, for each animation, I would have one state, but you don't have to do that. And for our simulation, in fact, we don't need to. So we'll just have two states. We'll have one called walk and one called run, okay? Two states, which will include not a single clip, but a random distribution of all of the runs and all of the, oh sorry, we don't have any walks, do we? We just have runs. Yes, so we'll just have one of these, one state with the 3 different runs inside. Okay, so yeah, this initial state, we'll just change it to run. Okay, so this is not the name of any of the runs that we've got already. So it's just sticking to the default one at the moment. But then when we connect it up to the DOP network, you'll see that we can randomize between what we've got in there. Okay. So that's all fine. Let me see, clip time. Could do that, but we can also do that within the sim. Okay, so we can add an offset to which point in that animation they're at. Okay, so they're not starting off in the same position. That can be very striking in a crowd that they're all doing exactly the same thing, you know. But like I said, we'll do that in here. Okay, so what I want to do, the idea for our project is to have a bunch of people running in a big circle. Okay, so let's make that. So I'm going to grab a circle. We want it on the ZX plane. Okay, let's make it a bit bigger. And then I'm going to scatter some points on this. So this will be where the agents are. Don't want 1,000 now. We might push it up later. We'll just start out with 100 points. Okay, and then if we connect that in, we'll get agents there. So another thing I want to do is have them, they're going to be running in a circle, so I want them to start out running, pointing in that direction, okay? Which can be controlled by the heading and the velocity. We'll just get rid of the velocity, okay? Because that can override the heading, or in our case, the normal. Okay, I'm just going to set the normal to be pointing in this direction, and then they will follow that. So I'll just show you, if I put this to the other direction, it should follow. There we go. See, so the velocity and the heading have to be the same. Oops. Put that to 0. Yeah, the velocity has to be following the heading for some reason. Yeah, we'll get rid of that and the heading, and we'll just set it up with the normal. Okay, and the way I'm going to do that is use another circle. Okay, and I'm going to use a NURBS curve here on the ZX plane. Let's give ourselves some more divisions. I want an open arc, and then if I drop a resample, I can get the tangent U, yeah, this tangent U attributes, which tells me which gives us a vector following the path of the curve, right? So sorry. So if I think we should be able to visualize that. If we just click on the tangent U, come into our visualizers, and change this to a vector. We want a marker and a vector. And you can see them now, but if I stretch them out, you might see, we want a vector trail. Is this showing correctly? It doesn't. Oh yeah, it is right. It's just really, really long. So you can see they're following the path and then just shooting out. I just kind of went overboard with the length. Okay, so we can use that to add normals to our scattered points, and then in turn to change where the agents are pointing, right? So I'll just use an attribute transfer here to get that tangent U onto my points. Geometry to get the points from. There we go. I think that was, no, not already here. So from the point, we just want the tangent U. Okay, and then we just need to assign that tangent U to the normal. So very simple bit of X. V at N is V at tangent U. Okay, and now there we go. Our agents are following the direction of the curve going around, so they're ready to run in that circle.